So as we move on, we're going to look at how we can work with regression when we actually have data that's been coded or we've been asked to code the data. So just a reminder that coding that we refer to is usually linear coding, and that means there's been a transformation of the data through the operations of adding or subtracting, multiplying or dividing. So that's the kind of coding that we're referring to. So here's a question where we've been told that 8 samples of carbon steel were produced with different percentages of carbon in them, and we're going to use C to represent the percentage of carbon. Each sample was heated in a furnace until it melted, and the temperature, which we're going to use the variable M for in degrees Celsius, at which it melted, was recorded. We've been given 2 coding formulas here, and we've been given the summary statistics. Sum of x squared equals 204 and sum of xy equals 478. What can we do from here? We've been told that this table has the coded results. The table is in terms of x and y, whereas the original data, as given in the prose, as given in the preamble, in the text-based context, is in M and C. So the summary statistics and the data in front of us is not the original data, it's coded data. We're going to go ahead and find the regression line of this coded data, and in our final step we're going to uncode the regression line so that we have a new regression line in terms of our original variables M and C. So I'm just going to start by collecting some summary statistics, that the 2 that were given already I'll write down, and also looking at the data I can simply just add up the top row to get the sum of x, 36, and add up the second row to get the sum of y, 144. Obviously we have 8 pairs of bivariate data, so n is going to equal 8. So this is enough for me to go ahead and find s of xx and s of yy. S of xx, I can actually speed up through this, is going to be the sum of x squared minus the sum of x squared over n, which gives us an answer of 42. We should be used to this by now. The S of xy is the sum of xy minus the sum of x times the sum of y all over n. Substituting in the correct values gets us negative 170. From there we can find b. B is S of xy over S of xx. That gets us 4.0476. I always like to try and stick to 4 decimal places around all of these values. It helps to maintain accuracy as we make our way through. Next, we're going to need to find A. A is y bar minus b x bar. Y bar is the sum of y over n. B, I just used this fraction in the line above. And x bar is the sum of x over n. 507 over 14, that equals 36.2143. Now that I've got A and B, I have enough information to generate my equation. The regression equation is going to follow the form y equals a plus bx. I'm going to substitute my A, substitute my B, and we get y equals 36.2143 plus 4.0476x. So now that we have the regression equation for y on x, let's see if we can generate the regression equation for m on c. We have the coding formula, the coding relationship that connects y with m. We're told that y equals m minus 700 over 5. We're also told that x equals 10c. So we're going to go ahead and substitute these expressions for y and for x. Okay, all we need to do now is actually just rearrange and make m the subject. My first line, I'm going to multiply through by 5. While I'm at it, I might as well multiply the 10c into its coefficient. So I'm multiplying 4.0476 by 50. And then I just need one more line. I'm going to add on 700. and that gets me an equation of m equals 881.0714 plus 202.38 c. This is the regression line of m on c. So if we were then given some further information about c, we could substitute it into this regression equation, into this regression formula, and get outputs of m. So using the coding, there's just a substitution that we have to do at the end that allows us to move from the coded regression line to the original data's regression line. Okay, so that's the step to look out for. I trust you've got the main part of the regression equation down after you've had so much practice. I'll just go through that a couple more times with you. In this question, we're told that the length x and the height y of crewmates are coded using this data. So are coded using these two formulae. Q equals x minus 30 and r equals 2y plus 11. If the equation of the regression line of r on q is as shown, r equals negative 3 plus 20q, what's the equation of the regression line of y on x? We're going to substitute 2y plus 11 for r, and we're going to substitute x minus 30 for q. From there, we're just going to expand, and through some sensible rearranging, we can isolate y, we can make y the subject, and we get y equals negative 307 plus 10x. Similarly, on this question, we have slightly different coding to look at. The maths marks x and English marks y of some K-pop stars are coded using these formulae. A equals x over 2 and b equals y minus 10. If the equation of the regression line, if that regression line is b equals 4 plus 5a, how do we go about making the regression line of y on x? We're going to substitute y minus 10 for the b, and we're going to substitute x over 2 for the a. Put those in. The first thing that I'll do is to expand the bracket, and I can move 10 over at the same time. Y equals 14 plus 5 over 2x. Or if you'd rather that as a decimal, 14 plus 2.5x. Okay, so get yourself some practice. It's just a step of substitution, but it's important that you keep track of the variables that are being used for the coded data, the variables being used for the real data or the original data, and that you conduct your rearranging, your manipulation, your algebraic manipulation carefully as you make your way through one to the other. Keep track of the context. What does each of these variables refer to? Is it coded data, original data, or a combination of both?